Okay, so I'm just going to cover this and post this on YouTube for you. So there is no class on Thursday for fall break. So I'm going to cover all three sections today. I'm going to cover 6.6, 6.7, and 7.1. So the first thing that we're going to talk about today is rational equations, or we can also call them fractional equations. And all it is just when an equation contains one or more rational expressions. And then the following is an example, right? So all a rational expression is just something, or it's just like fractions, right? You're just dealing with fractions. That's an example of a rational equation, right? So it's rational because we have fractions, and it's equation because we have the equal sign. Okay? Okay, so one thing that you might notice right away is that we have variables in the denominator, okay? So it's going to be really hard to solve this if we don't get rid of those fractions. So the first thing that we can do is we can find the LCD of all three of these fractions up here, right? So remember, the LCD is just our least common denominator. And we can multiply both sides by that least common denominator. And in doing so, it will get rid of all the fractions for us, okay? So what we're going to do is we're going to solve these. We're going to solve for a variable, just like we've done before. But the first thing we're going to do is, again, multiply each side by the LCD. Okay? So in this first one, if I look at these denominators, right, it looks like my least common denominator is going to be 5x, right? Because we have a 5 here, we have an x here, and we have a 5x here, right? Between all those three, 5x is going to be our LCD. So our LCD is 5x. So what I'm going to do now is I'm going to multiply the left side by 5x and the right side by 5x. Okay? So I'm going to write that. I'm going to multiply the left side by 5x, so 7x minus 4 over 5x. And then I'm going to multiply the other side by 5x. So we have 9 over 5 minus 4 over x. Okay? So this side, the 5x's will cancel. I'll just get 7x minus 4. So I get 7x minus 4. And then on the right side, I'm going to multiply through. And when I multiply through, we get this multiplied by this. The 5's cancel, and we're left with an x. So we get 9x here, 9x. And on this side, 5x multiplied by 4 over x, the x's cancel. We have 5 times 4, which is 20, right? And we still have a subtraction sign between those. Okay, so now that I've done that, now I can solve for x, right? So we've already dealt with these problems before, so that's pretty easy. So I'm going to subtract all the x's so they all go on one side, and then all the constants go to the other side. So I'll add 20 on both sides, subtract 7x on both sides. So we get a positive 16 over here, and over here we get 2x. Right? Divide everything by 2, and we get x is equal to 8. All right. So pretty simple for these, right? So all we're doing is just trying to get rid of all the fractions, so we just have just like a line of what we've done before, right? So easy to solve equations. Okay. All right, so we'll go to the next page. So the next page, if you want to read this, you can. Basically just what I've said before, you're just trying to find the LCD, multiply both sides by that, and in doing so, you get no fractions, so it'll be a lot easier to solve. So the only special thing is we might have to list the restrictions that we have on a variable, okay? And the restrictions are we don't want the denominators to equal 0, okay? So if I look at these, this one's pretty obvious, right? X can't equal 4. Right? Because if it equals 4, we divide by 0. So x can't equal 4, cannot equal 4. In this one, if I set this equal to 0, we find out that x can't equal 3.5. Okay? Okay, so x can't equal either of those values, right? Which is not a problem. So if I look at these two equations and I want to find the least common denominator, well, this is an x minus 4, and this is a 2x minus 7. So I think what I want to do here is I want to multiply this side by 2x minus 7 and multiply this side by x minus 4, right? I'm sorry. Right, so what we're going to do is just like cross multiplying, right? So I multiply these and these, right? So just like we're canceling the fractions out, we're just multiplying both sides by x minus 4, and then we're multiplying both sides by 2x minus 7. Okay? So if I do that, we get 3x plus 1 multiplied by 2x minus 7. And then on the other side, we get 6x plus 5, right, multiplied by x minus 4. Okay, so we've done that. The next thing that we can do is distribute, right? So we can FOIL this and FOIL this side. So if I FOIL this side, we get 6x squared, or we get minus 21x plus 2x minus 7. And that's equal to, we'll distribute the same thing on this side, we get 6x squared plus 5x minus 20x minus 20, right? And then all we have to do now is just combine our like terms. So if we combine our like terms, we see that the x squared terms are going to cancel, right? So if we subtract those will cancel. And then on this side, we have a negative 19x, right? So I'm going to simplify this down. Negative 19x minus 7. And on the other side, we get, sorry, this should be 24. So we get 5x minus 24x. We get a negative 19x minus 20. Okay. And we can simplify this even more, right? So the first thing I think I'm going to do is I'm going to add 19x to both sides. And you'll see when I do that, both of these cancel, and we get negative 7 equals a negative 20, right? And we can't have that. We can't have negative 7 equal negative 20, right? That doesn't make sense. So what that's saying in the context of this problem is that there's no solution, right? Because we don't have any variables to solve for anymore. So we say that there's a 0 with a slash through it just means no solution. Okay. Okay. So we get no solution on that. I will move on to the next page. So on the next page, this one says we're going to solve this one, right? So we have an example of a rational equation again. So I think what I want to do first is I'm going to factor this x squared plus 2x minus 8. So what I'm asking here is what multiplies the negative 8 but adds to a positive 2, right? And in this case, I think it's what? X plus 4 and x minus 2. So we get 2x minus 1 over x plus 2, x minus 4. Okay. Actually, x plus 4 and x minus 2, right? Should have written it the other way. X minus 2 and x plus 4. And then we're adding that to x plus 4 over 2, or 2 over x plus 4. And that equals 1 over x minus 2. Okay? Okay, so we've done that. Now we want to find our least common denominator. So in this case, our least common denominator would be what? X minus 2, x plus 4. So I'm going to multiply everything on the left side by x minus 2, x plus 4, and multiply everything on the right side by x plus 4, x minus 2. Right? So we're just multiplying both sides by x plus 4, x minus 2. Right, so we're doing that on both sides. So if I multiply this one by x plus 4, x minus 2, the denominator cancels. I get 2x minus 1. And if I multiply this by x plus 4, x minus 2, the x plus 4's cancel, and we just end up with an x minus 2. So we get this plus 2 multiplied by x minus 2. And then on the right side, if we multiply this by the right side, the x minus 2's cancel, and we just have an x plus 4 left over. So 1 times x plus 4. Okay? And then now we just solve just like we've done before, right? We simplify everything as much as we can, and then solve. So I'm going to do the left side first. I'm going to distribute here first. So we get 2x minus 1 plus 2x minus 4, and that equals x plus 4. And I think what I want to do is I'm going to get all the x's on the left side and all the constants on the right side. So I'm going to add 5 on the right side. And then I'm going to subtract an x on this side. Subtract an x. Right, so if we see we have 2x plus 2x, which is 4, minus x, we get 3x on the left. And on the right, 4 plus 5 is 9. And then finally, to simplify that, we just divide by 3 on both sides. Divide by 3, we get x equals 3. Okay, simple enough. The next question, we're going to do the same thing, right? We have to find what they have in common, their least common denominator. And I see that one's a 2x and one's a 5x. So I think that their least common denominator here is going to be 10x. So I'm going to multiply the left by 10x, multiply the right by 10x. And in doing so, the x and the x cancel, right? And then 10 divided by 2 is 5. So this becomes 5 multiplied by x plus 6. This one becomes 2 multiplied by x plus 24. And then the right side becomes 20x. And then solve as normal. We'll simplify by distributing the 2 and the 5. So we get 5x plus 30 plus 2x plus 48. And that equals 20x still. And I think what I want to do is I'm going to subtract the x's on this side to get them all over here. So if I add those together, we get 7x. So I'm going to subtract this side by 7x, subtract the other side by 7x, and then we can combine our like terms. So here we get 78, and that equals 13x. And then the very last thing we can do is divide by 13 on both sides. So after we divide by 13 on both sides, we just get x by itself on the right or the left, it doesn't matter. I'll just switch the position. So we get x equals 78 over 13. And let's see if that simplifies. So 78 divided by 13, yep, it simplifies to 6. So x is equal to 6. Okay. All right, so we'll keep moving on. So we'll do one more before we do a word problem. So this one we're going to solve again. If I look at my least common denominator, I think my least common denominator is going to be x plus 1 multiplied by x plus 6. So I'm going to multiply both sides by x plus 1, x plus 6. Okay. So the left side, the x plus 1s will cancel. So we have x minus 3 multiplied by x plus 6. And on the right side, the x plus 6's cancel. So we have x minus 2 multiplied by x plus 1. Okay. And then as normal, we'll distribute the x minus 3 into the x plus 6, and then the same thing on the other side. So we get x squared minus 3x plus 6x minus 18. And that's equal to, we get x squared minus 2x plus x minus 2. Then the first thing I notice is the x squareds. If I subtract an x squared on both sides, those cancel. And then let's combine like terms. I think that'll be the easiest thing. So this will be 3x minus 18. And that equals negative x minus 2. Right? So I'm going to add an x on both sides. And then we'll add 18 on both sides. So we get on this side 4x is equal to negative 2 plus 18, that's 16. Okay. Divide by 4 on both sides, we get x is equal to 4. Okay. So x is equal to 4 is our solution to this side, or to this equation. Okay. So what if we have something a little bit more complicated? What if we have something like this, where maybe we don't have nice numbers anymore, right? So we have decimals and we have fractions. So we can use rational functions, and we can kind of solve those rational functions and find an answer for x that satisfies this equation, right? So this is an example. They use it to model learning, so how fast somebody can learn, right? So they use it as a function of the number of trials on a particular task, or like how many trials it takes to successfully do some task, right? For however many failures they have. And some people might call it a learning curve, right? So we have f of x is equal to this, right? And we say f of x is just the proportion of correct responses after x trials, so however many trials they have, right? So if we plug in, or if we say if x is equal to 0, right? So there's 0 correct answers, there's 0 correct responses. And then if we have 1, so that this is equal to 1, then all the responses are correct, right? So we have 100% of the responses are correct. So it says then the graph shown on the next slide, right? So I think it's something that's kind of like this, if I show it, right? So we kind of go down to 0, and we go and kind of level out at 1, right? So we just kind of level out like that, is the graph to this. So then the question is, how many learning trials are necessary to have half the responses correct, okay? So what we're saying is, if this thing is equal to 0.5, how many correct responses, or what is x in this case, right? Because that's just our number of correct responses. So what I'm going to do is I'm just going to set this equal to 0.5, and then I'm going to solve this rational function. Right, so I have 0.9x minus 0.4 over 0.9x plus 0.1. That's equal to 0.5, right? So what I'm going to do now is look for my least common denominator, right? And this is 0.5 over 1, right? So we just have 1 for a denominator there. So our most common or least common denominator is just exactly what's down here. So I'm going to multiply both sides by 0.9x plus 1, and I'm going to multiply the other side by the same thing, 0.9x plus 1, right? I'm just multiplying both sides by the denominator. And what that's going to accomplish is it's going to cancel these two, right? Because we have this in the numerator, this in the denominator. And we're left with a 0.9x minus 0.4 over here. And on the right, we have 0.5 or 1/2 multiplied by this, right? So that's just the same thing as dividing by 2. So we'll get 0.45x plus 0.5 on the right. And then now we just have to solve for x, right? So I'm going to subtract 0.45x on both sides. So we get 0.45x. Then I'm going to add 0.4 on both sides. We get equal 0.9, right? 0.9. And then to solve for x now, we just divide both sides by 0.45. Right, so this will just be x on the left. And on the right, we'll have 0.9 divided by 0.5, which should just be 2. Okay. So what this is saying is that they have to have 2 learning trials, right? So it's just answering our question. We have to have 2 learning trials to have half of our responses correct. So I'll label it learning trials. Okay. Okay, we'll move on to the next part now. So the next part, it's another word problem. So this word problem says that this function of x models the cost in thousands of dollars to remove a percentage of the lake's pollutants. So it says if the voters of a city commit to $120,000 for a project, right, what is the percentage of the pollutants that can be removed? Okay? So all we're doing is saying f of x is equal to 120,000, and I want to find what x is, which is just the percent of the lake's pollutants that we could remove. Okay? So I'm going to say 120x over 100 minus x, and that's equal to 120,000, right? Because that's just how much that they're willing to commit to this project. Same thing, we're going to look for our least common denominator, which in this case is just 100 minus x. So I'm going to multiply both sides by 100 minus x. Multiply that side, multiply this side. Right, so we'll get 120x on this side. I apologize, it should just be 120 here because it's already in thousands of dollars, right? So it should just be 120. So 120 multiplied by this, we get Let's see, that's what, 100 multiplied by 120, that's 12,000. That's 12,000. And then 120 multiplied by a negative x, we have minus 120x. Right? So the next thing we do is add 120x on both sides. So add it on both sides. We get 240x equals 12,000. And then just divide everything by 240. Right? So after we do that, we just get x on the left. And on the right, we get 50. Okay. So to answer our question, what percentage of the lake's pollutants are removed? Well, it's just 50%, right? So it's 50% of the pollutants. 50% of the pollutants. Right, so all we're doing in these problems is just making or rationalizing this, right, by getting rid of the denominator on both sides, and then just solving for x just like we would do any other way before. Okay. All right, so we'll move on to the next part. So this will be the next section. It's going to be kind of similar to what we've done before, but it's going to add a little bit to it. Okay? So if I just give you a formula, right? So if I give you this formula and I tell you, hey, I want you to solve for some variable, right? So in this case, we have r that we're trying to solve for. So if I ask you to solve for that variable, and notice that it's in the denominator, right? But when we're solving for a variable, we need to get it to like r equals something on the right here. So the way I can do that is just what I've done in the last section, right? I can just rationalize the denominator, right? So what I'm going to do is I'm going to multiply both sides by the least common denominator, which in this case is r plus 1, or r plus r, right? So I'm going to multiply both sides by r plus lowercase r. Right, so on this side, these cancel, we just end up with an e. So on the right side, we end up with e. And on the left side, we end up with capital R plus lowercase r multiplied by I is equal to e. Right? And then my goal here is to still solve for this capital R, because I want it in this form. R equals something over here, right? Something. I don't know what it is yet. So instead of distributing this I to both of these, what if I just divide both sides by I? So I'm going to divide everything by I, right? Because that'll get rid of the I over here. I'm sorry, this should be in parentheses as well, because I'm multiplying the whole thing. So I'll divide everything by I, and then I get R plus R over here, and that's equal to E divided by I, right? And then the last thing I have to do is just subtract the R on both sides. So you have capital R equals E over I subtracted from lowercase r. Right, so all I'm trying to do is just kind of shift the problem around to be able to find what R, or capital R, is equal to, right? Or whatever variable we want to solve for. So we're just kind of manipulating the equations. Okay. So what if I want to solve for x in this problem? So I think what I want to do first is I want to rationalize everything, okay? So I think what I'm going to do is rationalize everything, and the way I can do that is look for my least common denominator, right? So in this case, my least common denominator would be, what, xyz, right? xyz. So I'm going to multiply the left side by xyz, and multiply the right side by xyz. Okay? So if I do that, the x's cancel here, and I just end up with yz. On the next one, I'm just adjusting the camera a little bit. On the next one, we get plus, the y's cancel, we get xz. And then the last one over here, the z cancels, so we just end up with xy. Okay? So the next question is, what can I do now? So I think what I want to do now is I'm solving for x, right? So I want to get all the x's on one side. So I think what I'm going to do is I'm going to subtract this xy on both sides. And the reason I'm doing that is because all my x's will be on the right side, and my non-x variables and stuff will be on the left, right? So let's subtract xz on both sides. Right, so on the left side, we just end up with yz. And on the right side, we have xy minus xz. Okay? And notice that I have a common x term on this side, right? This shares an x and this shares an x. So what I'm going to do is I'm going to factor out that x, just like we've done before. So we get yz is equal to x, y minus z. I'm going to factor out that x. And then I'm going to use something like I did up here, right? Where I had this I on this side and I didn't want it on that side. So I divided both sides by I. Well, on this side, I don't want this y minus z. So I'm going to divide both sides by y minus z. And if I do that, and I'm going to switch the x to the other side, we get x is equal to yz divided by y minus z. Right, because we're just dividing by y minus z on both sides. Right? And that's all I have to do, right? I solved for x because it's on one side by itself, and everything else is on the other side. Okay. All right, so all we're doing is either making or solving these equations for certain variables, right? So what if I want to do maybe a word problem that's a little bit more complicated, right? So this kind of goes back to the cost functions that we talked about a few weeks ago. So it says a company is planning to manufacture small canoes. So they have a fixed monthly cost of $20,000, right? So that's just how much it costs to keep the lights on, to pay their workers, stuff like that. And then it costs $20 to produce each canoe, right? So just how much material it costs, manpower, stuff like that, to make each canoe. So if I want to find a cost function of producing X canoes, right? So that'll be part A. So my cost function, so how much does it cost to make the canoes, right? Well, I know that it's going to cost $20,000 every month, right? But on top of that, it's going to cost $20 for each canoe, right? So it's going to cost $20,000 just to operate each month, plus $20 for each canoe that they make. Okay. Okay. Then B says, what's the average cost of producing X canoes, right? So this is C bar, right, or just the average cost. And if I look at this, well, I know this is how much it costs each month to produce X canoes, right? But I want the average cost. So what I can say is, well, I can have $20,000 plus the $20 for each canoe. And to find the average of how much it costs for each canoe, I can just divide this by however many canoes that I made that month, right? So that's how I can find the average cost, is just dividing by however many canoes I made, right? Because that's just like how you find the mean or find the average of something in the first place, is just add up how many you have and divide by how many there are. Okay? So that's our average cost. It's just the operating cost plus however many canoes we make divided by the number of canoes, right? Or the cost per canoe divided by how many canoes we have. Okay. And then our last part, C, says how many canoes must be produced each month for the company to have an average cost of $40 per canoe, right? So what we're saying is, how many X's do we need, or how many canoes do we need? So each canoe is worth $40, right? So this is my average cost, and I want to know, when is that equal to 40? So we have $20,000 plus 20X over X, and that's equal to $40, right? So my average cost of my canoe is $40. Right? And notice that this is basically what we've been doing before, right? We're just solving for X here. We're just solving for our variable. So what I'm going to do here is rationalize this, right? And the way I can do that is multiply by X on both sides. So I multiply by X, we get 20,000 plus 20X, 20,000, and I'll actually move it up to the top so I have a little bit more room. Move it up there. So on the left side, the X's cancel. We get 20,000 plus 20X is equal to 40X. Okay. Then I'll subtract 20x on both sides. So we have 20,000 is equal to 20x. Divide both sides by 20. And we get x on one side, right? If we divide both sides by 20, we get x on one side by itself. And on the other side, we get what? 1,000, right? So what this is saying is if you build 1,000 canoes that month, then the cost per canoe is going to be $40. Okay. All right, so we've covered that one. Let's move on to the next page here. So on the next page, we're going to talk about time and motion. So it's just like we've been doing before. We have this equation, right? Maybe in one of them I'm going to ask you to solve for the distance, or maybe another one I'm going to ask you to solve for the rate, and so on, right? So we've already solved for time here, but maybe I'll ask you to solve for the other ones. Okay. Okay. So let's go on to this example here. So it says an engine pulls a train at 140 miles. Then a second one whose average rate is 5 miles per hour faster than the first engine takes over and pulls the train 200 miles. So it says the total time required for both engines is 9 hours, right? So let's say that the time, or let's say we're going to use this, right? So we want to know for the first one, the first engine, we want to know the distance that they traveled and the rate that they traveled in, right? So if I look at this, I know that the distance that the first one travels is 140 miles, right? And I know that they traveled at a rate r, right? I don't know what r is, but I'm just going to say they traveled at some rate r. Okay? And if I add that to the second one, well, the second one traveled 200 miles, right? And we know that the rate that it traveled was 5 miles faster, right? It was 5 miles, or 5 miles an hour faster, right? So it traveled this in less time, right? And that's why I'm adding the 5. Okay. And we know that the total amount of time that it took, right? The total amount of time that it took for these two to travel was 9 hours. Right? Oops. Was 9 hours. And before we solve this, remember R is just the rate that the first one traveled for. And that's what we're trying to find, the average rate of the first engine. Okay? And then notice that this equation right here is just another rational function, right? So we're solving for R, but it's in the denominator. So to get it out of the denominator, I need to multiply by the least common denominator, right? So my least common denominator here, it looks like this is an r plus 5 and this is just an r, right? So I think what I'm going to do is I'm going to multiply everything by r and r plus 5, right? Because r is different than r plus 5. So I'm going to multiply this side by r plus 5, and multiply this side by r and r plus 5. Okay? So if I do that, we see that the r's cancel here, right? The r's cancel here, and then we have 140 multiplied by r plus 5. 140 multiplied by r plus 5. And then this one, the r plus 5's cancel, we just get an r. So we have 200 multiplied by r. And on this side, we have to multiply all those together, right? So this multiplied by this is 9r. 9r multiplied by this is 9r squared. 9r squared multiplied by 5, right, which is plus 45r. Right? These multiplied together and then distributed to that. Let's simplify the left side here. If I simplify the left side, this is 140r plus 5 times 140, which is 700. And I forgot to add here, plus 200r. Right? And then on the right side, we get 9r squared plus 45r. Okay? And then now I can get all the r's on one side, right? So I'm going to get all the r's here. So I'm going to subtract 340r from this side. So subtract 340r. And I got that from adding these two together, right? So I'm going to subtract 340r on both sides. And then notice that this side is just 700. And this side is 9r squared. And then 45 minus 340 is a negative 295r. Okay. And then the next question is, where can I go from here? Well, notice that this and this, if I subtract 700 on both sides, we end up with a quadratic equation, right? So if I subtract 700 on both sides, we get 0 equals 9r squared minus 295r minus 700 equals 0. And the question is, how can I solve for this? So I think the easiest thing, so we don't have to do any guesswork, is going to be to use the quadratic equation that I showed you before, right? So we had, instead of x, I'll write r is equal to negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. And that just comes from the coefficients of the equation down here, right? So we have 9, negative 295 for b, and negative 700 for c. A, b, and c. Okay. So if I plug those into the equation up here, maybe I'll just look up a solution really quick so we don't have to go through that. Give me just a second here. So if I do that, if I plug that into this equation, we get r is equal to 35 and negative 2.2 repeating. Okay? So I just plug that in on my calculator just to find out what those are. But if you use the equation, you'll get the same answer. So you'll notice here that we get two solutions, right? So which one's correct? What's the rate of the first train? Rate of the first train, right? And if I look at this problem, the train only goes in the positive direction, right? It only goes a positive distance. So I know that this negative 2.2 repeating can't be my solution because it's a negative, right? It's a negative. So I know that my rate is going to be 35 here. So what I can say is that my first engine's rate is just 35 miles per hour. Right? So it's just 35 miles per hour. So that's the average rate of the first engine that pulled the train. Okay. Let's move on to the next page then. So we're going to do a similar problem. So this one says, after riding a steady speed for 40 miles, a bicyclist had a flat tire and had to walk 5 miles to a repair shop. And it says the cycling rate was 4 times faster than the walking rate. And it says if the time spent cycling and walking was 5 hours, what was the rate of the cyclist riding? Right? So we're going to set up a similar problem, right? We know that he went 40 miles first, right? And we know that he went 5 miles after. And we know that the cycling rate was 4 times faster than the walking rate, so over 4x. And we know that his rate walking is just x, right? Because it's 4 times x is his cycling speed. And then after that it says it took them a total of, 5 hours, right? Right, so this just goes back to our time is equal to a distance divided by rate, right? So that's just the distance he traveled divided by the rate that he traveled, right? And added these together, that's our total time that he traveled. Okay, so same thing, we're going to solve by eliminating the denominators. So I see that the least common denominator here is going to be 4x. So I'm going to multiply both sides by 4x. So these 4x's will cancel, we'll just end up with a 40 here. And the x's will cancel here, we end up with 4 times 5, which is 20. Right? And on the right side, we just have 20x. And then finally, what we'll do is just divide both sides by 20. 60 divided by 20 is 3. And x is equal to 3, right? So the question says, if the time spent cycling and walking was 5 hours, at what rate was the cyclist riding? And remember that x is our walking speed, right? That's our walking speed. And our cycling speed was specifically 4 times faster, right? So I need to multiply this side, or both sides by 4, right? So we get 4x is equal to 12. If I multiply both sides by 4, and 12 is my miles per hour, right? That's my cycling speed. So that one was a little bit tricky, right? Because we kind of solved it backwards a little bit, right? So we started with our walking and then scaled it up to our cycling speed. Okay. Okay, so we've done 2 examples like that. Let's try a little bit of a different one now. So this different one says, a hurricane strikes in a rural area is without food or water. So it says 3 crews arrive. One can dispense the supplies that they need in 10 hours, a second one in 15 hours, and the third one in 20 hours. Okay? So it says, how long will it take all 3 crews to working together to dispense that food and water? Okay? So we're going to write an equation like we've done before. And the equation specifically says, if they work together, how fast can they do it in X hours? So we're going to do, it says construct a table to find the fractional part of the task completed by the 3 crews in X hours. Right? So we know that the first one can complete a tenth of its job in 1 hour, right? And we know that they spent X time working together, right? We don't know how many hours that is. So their fractional one is just these multiplied by together, so we get X over 10. So we can say that the first crew spent X over 10 hours helping out, right? In the second crew, it's going to be something very similar, right? Our fractional for the second one is 1 over 15. But we know that they worked for X hours together. So instead of X over 10, it's going to be X over 15. Right? And then lastly, we have the third one that does it in 20. So we have X over 20 that we add to it. Okay? And then the final question is, what is this equal to? What is this equal to? Well, if we look at it, we want to find when they, or how many times it takes for them to complete it in, or how many hours it takes, right, to complete giving all the people in the rural area food, right? So our question is, how long does it take, or how many hours does it take? Well, it's going to take X hours, right? We don't know what X is yet. So then the question becomes, how can I solve for this? So we have to find a number that all these have in common, right? So we can simplify this. And I think the first one that I can do, or the simplest one that I can do, is I think 60, right? So if we multiply the left and the right by 60, that'll cancel all the denominators. Right? So this one will become 6x. This one will become, let's see, 4x. And this one will become 3x. And then finally, this side becomes 60x. Right? So we'll simplify everything. Actually, this side actually is wrong, right? It should be something different. Fractional part. Give me just a second to look this problem up. I think I'm missing the one side. So that right side should be different, right? If you know it, feel free to either shout it out or type it in chat. I'm going to look it up really quick, though, just to make sure I'm doing it right here. Just a second here. This is just 1 second. Yeah. Okay. Okay, so if we add these together, it should just be 1, right? Because that's just 100% of the time that it'll take, right? Sorry about that. We'll go back to that. So this problem should just be 1 on this side. It should just be 1 on this side. So 1 multiplied by 60. Oops. Right, because that's just 100% of the work that they have to do, or just 1. Okay. Sorry about that. Okay, so we get the left side is equal to 6x plus 4x plus 13, or plus 3x is equal to 60, right? So we'll combine our like terms on the left. We get 13x equals 60. Divide by 13 on both sides. We get x equals 60 over 13. Okay. Okay. So we know that x is 16 over 30. But the question is, how long will it take all 3 of the crews working together to dispense the food and water? Well, it should just be 16 over 30, right? Because that's just the time that we spent working together. So it'll take them 16 over 30, or yeah, 60 over 30 rather, sorry, or about 4.6 hours working together. Right? So it'll take them about 4.6 hours working together to finish this job, right, of passing out the food and water to some rural area. Okay. All right, so let's see what we have next. So next is our last section for today, and this should be pretty easy. I'm sure a lot of you have done this before, but we're going to talk about the square roots, cube roots, and roots of any size that we want to talk about, right? So we have a new category of expressions and functions. So it's the reverse operation to squaring, right? So square rooting. So we use this symbol to denote the principal square root, right? Or just the positive square root. So this is specifically the positive square root. And it's called the radical sign. So it says the number under the radical sign is called the radicand, right? Which is, you can use this picture, the radicand. It's just whatever's under the root. And then together, we refer to the radical sign and the radicand as the radical expression, right? So just everything there is the radical expression. Okay, so we'll talk about specifically the principal square root. It says if a is a non-negative real number, the non-negative number b such that b squared equals a denoted by the b is equal to the square root of a, right? Or all we did is just square root to both sides. It says the principal root of the principal square root of a, right? So all we're saying is the principal square root is just the positive square root, right? Or they specifically say non-negative because it can also be 0, right? So it's either the positive square root or it could be 0, either one. Okay, so if we want to evaluate these, so we want to find out what the positive square root of these are. If we look at this one, this is a negative, right? And there's no two numbers that we can do, that we can have in the real numbers, that'll multiply to a negative number, right? So for a. So for a, there's specifically no solution. There's no two positive numbers that we can multiply to get to a negative 16. Okay? For b, we can simplify this a little bit by adding these together. So if I add those together, we get the square root of 169, if I add those together. And the positive square root of 169 is 13. Okay. C, I can't add these together, right, because they're both not under the radicand. So what I'm going to do, or the radical rather, so what I'm going to do is take the square root of this, which is 12, take the square root of this, which is 5, and add those together, which is 17. Right, so I'm just taking the square roots individually and then adding them together at the end. Okay. All right, we'll go to the next page, and we're going to do a few more of these. So the square root of 64. So I want the positive number when multiplied together is equal to 64. And in this case, it's just 8. Okay. The next one, I want the negative of the square root of 49. The square root of 49 is 7. And I'm taking the negative of that, which is just negative 7. Okay, one exponent rule that you're probably familiar with, or hopefully, if you have the square root of a fraction, that's the same thing as taking the square root of the top divided by the square root of the bottom. So you can kind of split them up. So the square root of 16 is 4, the square root of 25 is 5. So we get 4/5 for that one. Okay. And then just as last page, when we add these together, we can do it since they're both under the radical. So that's equal to the square root of 25. 9 plus 16 is 25. Square root of that is 5. Okay. Okay. So what if we get something a little bit more complicated? What if we get something like this? Now we have variables in there, right? So I want to find the variable, right? So we have the negative of the square root of 2x plus 1. And I want to know, what is the answer when x is equal to 4? What is the answer when x is equal to 1? What's the answer when x is equal to negative 1/2? And then finally, what's the answer when x is equal to a negative 1? Okay. So we'll do the first one. We'll do g of 4. So this is equal to the negative of the square root of 2 multiplied by 4 plus 1. Right? Plus 1. Notice that when we multiply this together, we get 8 plus 1, which is 9. Okay? So we have the negative square root of 9, which is just equal to negative 3. I can do g of 1. Right? So g of 1 is equal to the negative of the square root of 2 multiplied by 1 plus 1. And that's just equal to the negative square root of 3. Right? And 3 isn't a perfect square, so I can't really deal with that, right? So I'll just leave it as that. Okay, the next one, I want to find g of a negative 1/2. So that's equal to the negative square root of 2 multiplied by a negative 1/2 plus 1. Okay. This multiplied together is negative 1. Negative 1 plus 1 is 0. The square root of 0 is 0. And the negative of 0 is 0, right? So this is the negative square root of 0, which is equal to negative 0. And the negative 0 is just the same thing as a positive 0, right? Just 0. Okay, and then the last question, g of negative 1. So I'll do that down here. G of negative 1. That's equal to a negative square root 2 multiplied by negative 1 plus 1. Okay. If I look at this, we get 2 multiplied by negative 1, which is negative 2, plus 1 is negative 1. This is equal to the negative of the square root of negative 1. And notice that we have a negative under here, right? So we can't have a negative square root because no two positive numbers multiply together to give us a negative 1. So this one has no solution, right? There's no real numbers that we can do that'll give us the square root of negative 1. Okay. We'll move on to the next page here. So this one, it's just like we've done before, right? So it says find f of 3. So I want to find what this evaluates to when x is equal to 3. So f of 3 is equal to the square root of 12 multiplied by 3 minus 20. And that's what? 36 minus 20. So this is equal to the square root of 36 minus 20. 36 minus 20, which is equal to the square root of 16, which is 4. Right? Okay. So now we'll get into some terminology. Now we're comfortable with that. We'll get into some terminology called the domain of a function. And that's just the, you can look at it as like the interval notation that we've done before. It's just all the numbers that we can plug in for x and still get a solution. Okay? So the domain is just the largest set of real numbers for which the value is defined, right? So if we put an x in, we'll get an answer out. And notice that when we do the square root, right, when we do the square root, we can only have non-negative numbers. Okay? So if I want to find the domain of this, I just need to find all the x's that I can that are going to be either equal to 0 or above 0, right? So I want to know when is the function inside the square root. So when is 3x minus 15? When is that greater than or equal to 0? Right? So that's where everything at 0 or above is defined, right? I'll get a positive answer. So we know how to solve these. We've done this before. So I'll add 15 on both sides. So we get 3x is greater than or equal to 15. Divide by 3 on both sides, we get x is greater than or equal to 5. So what I'm saying here is as long as I plug in a number between 5 and infinity, I'm going to get a valid function, right? Or I'm going to get a valid answer. So if I want to write this in interval notation, right, we could say it's including 5, right, and it goes all the way up to infinity. Okay, so now I'll do the next one. So I want to know when this is greater than or equal to 0. I'll add 27 on both sides. Divide by 9. And we get x is greater than 3. So what that means is that we include 3, right? And we go all the way up into infinity. Oops. All the way up to infinity. Okay. So now we covered, that's our specific one, or domain. So that's an important term to remember for your homework. Now we'll go on to a word problem that uses these radicals, right? Okay, so it says police use the function f of x equals the square root of 20 multiplied by x to estimate the speed of a car in miles per hour based on the length x in feet of its skid marks upon sudden braking on a dry asphalt road. So it says use the function to solve the following problem. So we have a motorist that was involved in an accident, right? The police officer measures the skid marks to be 45 feet long, right? So we know instantly 45 is x, right? It's just the length of the skid marks. So we know x is 45. And then it says estimate the speed at which the motorist was traveling before braking. And then it says if the posted speed limit is 35 miles per hour and the motorist tells the officer she was not speeding, should the officer believe her and why? Right? So all we need to do is plug in 45 for x, right? So we want to know the function of 45, and that equals to the square root of 20 multiplied by, or substitute in 45, right? Okay, so what we can do here is just do 20 times 45, right? So that's the square root of 900, which is 30, I believe. Square root of 900, yeah, which is 30. Okay. So we know that her speed was 30 miles per hour, right? Which is below the posted speed limit. This is less than 35. I guess we could do it or equal to, right? And then the question is, should the officer believe this lady that was involved in the accident that she was not speeding? Well, based on the data here, it looks as though she was going 30 miles per hour, right? So the officer should believe her in this situation. Should believe her, right? Because just from the data, we know that she was going 30 miles per hour, which is definitely less than the 35 that was the posted speed limit. Okay. Let's move on from square roots. Or maybe not. We'll do one more word problem here. So we'll do one more word problem. So this one says an hour-long TV show is actually much shorter when you consider the amount of clutter, including the commercials, plugs for other shows, stuff that's not the actual program, right? So we have this square root function. So m of x is equal to 0.7 multiplied by the square root of x plus 12.5. And it just it models the average number of non-program minutes in an hour of primetime cable X years after 1996. So it says use the function to predict how many cluttered minutes rounded to the nearest tenth there will be in an hour in 2014. So remember, X is just the number of years after 1996. So to find what my X is, I just have to do 2014 minus 1996, right? We do 2014 minus 1996, and we get 18, right? So that's the number of years after 1996. And then we just plug in 18 for X. So m of 18 is equal to 0.7 square root of 18 plus 12.5. Right, so that's pretty easy. We take the square root of 18, which is about 4.24, multiply that by 0.7. So multiply that together, we get about 2.97. Add that to 12.5. You should get about 15.47. So we want to round that to the nearest tenth, right? So 15.5. And that's how many minutes or cluttered minutes there are in an hour-long program, right? Or in an hour. Okay. So we'll go over another definition really quick. So if I want the square root of a square, notice that we have inverse operations, right? We have the square root in a square. So those will just cancel, right? But when I square a number, I get a positive number in return, right? Because we'll have a negative, if we have like -3 multiplied by -3, we get a positive 9, right? So if I have two negatives, if I have two positives multiplied by each other, I also get a positive 9. So it doesn't matter if it's a negative or a positive being multiplied by itself, I get a positive answer out, okay? So when I have the square root of a square, they'll cancel out, but I have to take the absolute value of an a because I always get a positive number after I square something, okay? So in other words, the principal square root of a squared is just the absolute value of a, right? So it's just the positive part of a. Okay? Okay, so if I have, let's say this one over here, right, and I want to simplify this. If I want to simplify this, I can do something like this. I can say, well, this is just the square root of 81 multiplied by the square root of x to the fourth. Right? So I can do that. I can split those up as long as they stay like that. Okay, so notice that I can do the square root of 81, right, which is 9, right, because that's 9 squared. And obviously 9 is a positive number, right? We're always taking the positive. And x to the fourth is just x squared, right? And I don't have to necessarily put an absolute value on the x squared because it's already squared, right? It's definitely going to be positive. It has to be positive. Whenever we square something, it's always positive, right? We can combine those back together. We get 9x squared. Okay. If we look at B, it looks a little bit more complicated, right? We can't use the tactic we just did of splitting it up since we're adding them together. But one thing we can do is maybe we can factor them, right? Like we've been doing before. So the question is, how can I factor this? Okay. So I want a number that multiplies to 49, two numbers that multiply to 49, right? And that adds to 14. And in this case, it's just plus 7, right? It's a positive 7 for both of them. And then you're like, hold on, wait a second. X plus 7 and x plus 7, if I multiply those together, sorry, that should still be in the square root. If I multiply those two together, well, that's just x plus 7 squared, right? So that's just x plus 7 squared, because I'm multiplying the same thing by itself. Okay? And then the question is, well, now what can I do? Well, we can do something like this, right? We have the square and the square root. So if I cancel those, we just get x plus 7, right? And we have to take the absolute value of that, right? Because we don't have a squared anymore, so we have to take the absolute value. Okay? That's our answer for that one. Okay, let's do a few more examples like that here. So we got 3 more on this one. So we have the square root of negative 7 squared. Well, negative 7 squared is 49, right? And we can also use the other rule that we've done, right, where we cancel those out, but we take the absolute value. So if I cancel those out, we take the absolute value of negative 7, which is just 7, right? Okay. Similarly, on the next one, we take the absolute, or we take the square root and the square they cancel, take the absolute value of the inside. Plus 8. Right, easy enough. Same thing on the last one. We can use that trick that we did on the first one and split it apart if we want, but I'm just going to do it here. So we take the square root of 49, which is 7, take the square root of x to the 10th, that's x to the 5th. Right? And we have to put that in the absolute value. Okay, so now that we've done square roots, we can talk about cube roots, right? So we're going to go up one more, right? So we have the cube root of a real number. It's just written as the root symbol, right? But we have a 3 up there now of a. And what this means is that there's some number b that when we cube it is equal to a. Okay? So if I look at g of x here, and all I need to do is just plug in these values, right? So what I'm going to do is I'm going to say, hey, g of 13, well, that's equal to a negative cube root of 2 multiplied by 13 plus 1. So this is equal to the negative 2 times 13 is 26. So plus 1 is 27. That's the cube root, right? And the number that's the cube root of 27 is just 3, right? 3 times 3 times 3 is 27. So we get the negative of 3, which is just the negative 3. So that's g of 13. Right? If I want to do the g of 0, if I plug in 0, we get this cancels and we just get 1, right? So g of 0 is equal to the negative cube root of 1, right? And 1 multiplied by itself 3 times is 1. So we can say this is equal just to the negative of 1, which is negative 1. Okay. And then we have one more. So this one we have negative 63 that we're plugging in. So g of negative 63. That's equal to the negative cube root of 2 times negative 63 plus 1. So 2 times negative 63 is a negative 126, plus 1 is a negative 125. So this is equal to the negative cube root of a negative 125. And what multiplied by itself 3 times is equal to a negative 125? Well, I know 5 multiplied by itself 3 times is a positive 125. So this just has to be the negative 5, right? Negative 5. So negative 5 cubed is equal to a negative 125. The negative of a negative 5 is a positive 5. So that's my answer on that one. Okay. All right, so that's the cube roots when I'm just plugging in numbers. Let's try a few more of them, right? So this one, instead of being given numbers that I'm going to plug in, I'm just going to say, hey, I want you to simplify this. So we already know that the cube root of negative 125 is a negative 5. Okay? And the cube root of a cube is just itself. So it's just x. Okay? We already know what the cube root of negative 27 is, right? That's just negative 3. And the cube root of x to the x cubed is just x. Okay. So those are simple enough, right? We can split them apart just like we did with these square roots. Okay, for the next one says find the indicated root or state that the expression is not a real number. Okay? So notice that we have an odd number up here, right? So this is saying what times itself 5 times, so I'll just say what times itself 5 times, right, is equal to negative 1. And the easiest solution, right, is, well, we can just multiply negative 1 by itself 5 times, right? So negative 1 multiplied by negative 1 5 times is equal to negative 1, right? And I can prove that to myself, right, because these negatives cancel, these negatives cancel, and we just end up with a negative 1. So negative 1 is equal to negative 1. So our answer for this one is just negative 1. Okay? So notice that what happens is these are in pairs when they cancel, right? So these are in pairs. So this is like negative 1 squared, and this is negative 1 squared. So as long as I have pairs, right, or in even numbers, they'll cancel out to a positive 1, right? So I'm going to use the same trick over here to see if I can find an answer. Well, this is negative 1 multiplied by itself 8 times, right? Or I can say, well, it's negative 1 squared multiplied by negative 1 squared multiplied by negative 1 squared multiplied by negative 1 squared, right? And I want to know, is that equal to negative 1? Right? So if I look at this problem, notice that these are all paired together, right? So they're all squared. So all these are going to be a positive 1 on the left. And we know a positive 1 is not equal to negative 1, right? So we know that there's no real solution to this. And one trick that you'll notice is that if this root here is odd, you can have a negative under the square root. But if it's even, you can't have a negative under the square root, or the negative radicand, right? So you can't have a negative radicand. Okay. Okay. So we've talked about square roots, cube roots, and now we're getting into higher roots, right? So we're kind of generalizing it. So we're going to generalize it even more. We're going to look at a few more examples. So this one says, find the indicated root or tell me that there's not a real number, right? So if I look at this one, I want to know what's the fourth root of 16, right? And then take the negative of that. So the fourth root of 16 is 2, right? And the negative of 2 is negative 2. Okay. I'll cross out this. It copied twice for some reason. Or I'm sorry, no it didn't. Sorry. All right, so we'll look at this next one. And I want to know the fourth root of a negative 16. Well, remember on the last page, whenever I have an even root of a negative number, I have no solution. Okay? I have no solution. And then finally on a C, notice that I have an odd number here in negative. So I get a negative 1, right? Negative 1 multiplied by itself 5 times is negative 1. Right? So easy enough. So if I have an odd root, I can have negative numbers. If I have an even root, I can't have negative numbers under the radical. Okay. So I think, on this last page here, whenever I have simplifying something, right? So if I have the nth root of something and it's to the nth power, right? If it's even, if n is even, like 2, 4, 6, 8, so on, we just get a, but we have to take the absolute value of it. So we need to have that positive number. Okay? And if it's odd, they just cancel and we're not worried about the absolute value. Okay? Okay, so let's look at these two here. And this one says simplify this first one. So I have the fourth root of something to the fourth power. So those will cancel, but I have to take the absolute value since it's an even radical, right? So for A, I get the absolute value of x plus 5. For B, I get these cancel, right? So these cancel, and look at it specifically here. So if I look at that problem specifically, we have two parts to it, right? So I know that the fifth root here, the fifth power here, and the fifth power here are cancel, right? So that's not a problem. But if I look at negative 32, I have to take the fifth root of that as well, right? So if I take the fifth root of that, well, notice that negative 32 is the same thing as negative 2 to the fifth power, right? So I'll take the fifth root of that multiplied by the fifth root of x minus 2, right? So that's just a negative 2 multiplied by x minus 2. Oops, x minus 2. Okay. And then if you want to, you can simplify that, right? Okay, I'm just going to keep cruising along. I'll get these last two problems done, and then we'll call it a night. And remember, we don't have class on Thursday. Okay? So these two, we have the fourth root and the fourth power. Those will cancel. We get x plus 6. And remember, since it's even, we have to take the absolute value. Okay? And then the last one, these are odd. So those will cancel. We get 3x minus 2. And since it's odd, we don't need the absolute value. Okay? Okay, if you don't have any questions, you're good to go. If you do have questions, feel free to stay. And then I'll upload this before I go home to YouTube. And I'll post an announcement or a link or something.